Hello, everyone. Welcome back. And we are going to pick up with Invoker. If you don't know what this series is or all about, please watch the first video in the playlist. That said, let's jump right in and let's check out Invoker and start with the type signature. Um, so we take a number and we take a string and then we return this function, right? So this is a function. Um, I find that the functions are like the weirdest ones versus object functions or list functions, relation functions. Um, but these can be very useful as well. So the function that it returns looks like it returns a curried variadic function, which takes an unlimited amount of arguments. It's a function that takes an A, returns a function that takes a B, and returns a function that takes a C and a D and a blah, 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 all the way down to N. And then an object, the variadic amount of functions, and then an object, and then it returns anything, right? So let's look here. So number is an arity, the number of arguments that the return function to take before the target argument. So however many of these, you need to tell it up front how many arguments you expect. And then an object, um, because it needs to know. And then a method, not a function, but a method, the name of any of the target object's methods to call. And then it returns a new curried function, right? So given an arity, which is a number, and a name, which is a string, the invoker function returns a curried function that takes arity arguments. So if it passes like three arguments, or past three is the number, it takes three arguments, and a context object. It will invoke the named function, a method, on the context object, right? So let me give you an example here. Let's say we want to use r.invoker, and we want to invoke the trim method of the string object like this. So the string in JavaScript has a prototype, and in that prototype, it has methods like trim to uppercase to lowercase, um, split, these things. And so trim, how many arguments does trim take? It takes zero. This will be our first argument, zero. And then the second is the name of the method that we want to invoke. And we have to pass it as a string. The name of the method would be trim. And then the third argument would be the context object. I'll just pass that here. Let me put this on its own line, get rid of some parentheses. Um, and we could just pass it like space, 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 banana, space, space, space. And if we run that, we get back a function. Okay. So zero and trim. What did I do wrong? It takes a function. We're saying it still takes another argument. Does that make a difference? Does make a difference. Interesting. Because it returns back a curried function. You tell it zero and trim. And if you look at these examples, yeah, even here, oh, okay. They actually mention that in here. If you look at this last or this code example here, note You can't simply pass some of the arguments to the initial evoker function. Um, so slice takes two arguments, and slice is the name of the method that we want to use, and then it takes those two arguments, so we can't go ahead and pass them. Like we just need invoker just needs strictly two arguments. The number of arguments the function or the method takes and the name of the method. So someone explained this as what we're doing is like if you think of the trim method on the string prototype, if you think of like the string prototype being a folder with all the string methods in it, we're lifting that function or that method out of the prototype and just making it its own standalone function. Um, so let's do one with one argument. What would one argument be for a string? Uppercase and two lowercase don't take arguments. Either just trim or trim start or trim end. Just trying to think from memory. We can use slice like they have. Let's do their example. So if we wanted to lift the slice method out of the string prototype because it works on strings or arrays, uh, and let's go ahead and trim this manually ourselves. If we just did this, we should get back banana, right? Because we're slicing from the beginning 0 all the way. But if we started, because if you don't give it the second argument, it just starts at the first argument and goes to the end of the string or the array. But if we slice from 2 to the end, we get function dot 2. Maybe I'm wrong. Maybe we can't slice. Um, oh, no, no, no. It's saying we're taking two or two arguments and I'm not passing any. So the two arguments would need to be. Oh yeah, I misspoke. I was thinking this is how many we want to or where we want to slice from. Um, I was just saying zero arguments. So zero arguments would start from the beginning into the end, go to the end. If we said one argument was slice and we passed that and say start at index 2, that's what's going on. Yeah, and we get Nana. So 0, 1, and we start at 2. But if we said, no, we want to provide two arguments and we want to do 2 to 5 or 4. Yeah. Can we do it all at in one set of parentheses? I'm thinking not, but we can. Can we do it curried? We can. Okay, so either way. And I wonder if we could just pass all these together at the same time. So start at 2, go for 4, and here's the data. And that works as well. So that's cool. Another handy one is this JSON method that is on the response object. So like you fetch from an API and you get back a response object, but you need JavaScript. So generally you'll do another await and then take the value of the response and call the JSON method on it. Uh, Here we can make our own as JSON method, or I'd call it to JSON, like that. And then so then we'd say r.invoker, and it takes 0 arguments. And well, that's it. It just takes 0 arguments. Oh, and the name of the method JSON as a string. Uh, but then I have to do a fetch call, and I don't think I can do fetch in Node, and I don't know where to fetch from anyway. So just we'll take their example if I can copy it. What is going on? Here we go. So we could fetch it, and then that returns a promise, and then we could call the then function and pass in as JSON. Just very concise, you know. Otherwise, we'd have to say like x x dot JSON and then invoke it with parentheses. That would do the same thing. Yeah. And the other thing I realized is that like I have my own library called Canary JS, which is very similar to Ramda. It's like a simpler version of Ramda where all I'm doing is simply currying the built-in prototype methods that we use all the time, like this. So like something with let's see, what's a good example? Come on, Brad, think. Um, hmm, I can't think of anything right now that takes more than one argument. I don't want to use slice because that's a little complicated. Let's use map. So if I made my own map, um, it would take a function and then it would take a an array called x's, and then I'm just gonna manually implement the built-in um, array method or how we would use it with the built-in map array method. But then I would say x's dot map with function, right? And so this is what invoker is doing ourselves. Like we could say const map underscore and r dot invoker and say that it takes two arguments. No, one, two. I mean, the data is an argument. I don't know, honestly. Let's just try one. We'll figure it out. And then the name of the method that we want to invoke as a string. And then we'll use, we'll log that map underscore, pass it the one argument. We'll just do inline x times two, like a double. Or we'll just do r dot multiply. We use random functions. So that's our mapper function. And then we would pass, and because I'm doing it manually, oh no, I'm not. First of all, let's call the map one. Let's call the one that I just made. And so it has to be curried because I've curried it. And we'll pass it our d.list, which is an array of 1, 2, 3, 4, 5. I started using some sample data in the last video. Yeah, we get 2, 4, 6, 8, 10. And if we replace that with the version of map that's using the invoker to lift map out of the array prototype, you'd still be able to do it like this if I've done it correctly. So save that. Yeah, and we get the same thing. Yeah, and if I say so one, it's taking like it's taking the function as the first one, and of course, map the one on the prototype automatically has the index, so we could say two arguments and make our own custom function that said it takes an X and an I for the index, and we'll just add the X to the I for no reason, since they're all numbers. Yeah, and then we get 13579. So instead of doing this, um, you could do it like this, where it's point free and it's automatically curried, or I should say optionally curried. You could call it both ways, I think. Let's try that by providing it the list is the second argument inside one function call. Yeah, and we get the same thing. That's invoker. It's pretty handy. It says see also construct, and we looked at construct before. It wraps a constructor function inside a curried function that can be called with the same arguments and returns the same type. And this has to do with, if I remember, being able to construct a new like basically instantiate an instance of a class without using the new keyword. So we use the r.construct animal, and it makes an animal. So animal, yeah, notice we no longer need the new keyword. So functional programmers are allergic to the new keyword. And when we use functional programming in JavaScript, we need to use very few reserved words, basically const, and then like import for import statements. Yeah, so that's Invoker. And if you want to know more about construct, Christopher went through that in great detail in the original series, and I recommend watching that anyway. It's much more high quality than this one. And I think since these are grouped together, I'll stop this video here and I'll pick up and we're going to look at is empty, is nil, is not empty, and is not nil. And if you notice, all of these are predicate functions. They ultimately return a Boolean. That one, that one, that one, that one, and is. Yeah, they all return Booleans. So a string of predicate functions, and that will finish up the eyes, functions that start with eyes. So we're making progress. And as we get further, since we've looked at like C also, um, by the further we get it down into the alphabetical list, the more and more we're going to encounter functions that we've looked at previously. So we'll either skip them or we'll just do a quick refresher on those functions. Thank you for spending your time with me. Tell a friend, and I will see you in the next video when we talk about a bunch of predicate functions.